Alright, so ladies and gents, just to finish the little bits on titration curves. So I've already said this to you, but we'll repeat it again. So you may be asked to just draw the shape of a curve, or you may be given data and have to plot it. And you will nearly always be adding 50 ml of base. The ratio in your equation for that particular thing will usually be 1 to 1, and if that is the case, then neutralization will happen roughly at the 25. The initial pH depends on whether or not we are starting off with a strong acid or a weak acid, and that influences the shape of your curve. And your final pH will depend on whether we have a strong base or a weak base. So this determines the pH at the start, and whether or not we have a strong base or a weak base is essentially where does my curve end, and this will make sense once you've seen the curves. There will be a jump in pH at neutralization, and you will have to select an indicator and tell them why it is you have chosen it, and it will make sense, as I say, once you see the curve. Now, I think that there are magic numbers for titrations, and these are my magic numbers. So 1, 3, 7, 10, 13, and you will see that we will use them as we go through our graphs. Now, I don't think this will play for me, so I am going to put this out of the way for a minute, and we now have a look at it here. So this is an example of a strong acid, strong base. So in my book, it's on page 152, and you have written strong acid versus strong base, and you have written start and end. So by start and end, I want you to recognize, is my pH, if it's a strong acid, does my pH start? I use the words high and low. So if I have a strong acid, my pH will be low at the very beginning, and if I have a strong base, my pH at the end will be high. So that's just kind of to help you to understand and see where it's going. So if I press here, you see that the blue line, the curve, starts low. It then shoots up, so this is the jump at neutralization, and then it's going to level off. So this is roughly 50 ml of base, so NaOH, against 25 ml of HCl. So you can see it's acidic at the beginning. It's got this kind of an S shape to its curve. So if you're okay now, we will go back here. So on page 152, where you have your graph paper, you are going to write at the top where it says start. It's going to start low because it's a strong acid. If you need to put that in, please do. And it's going to finish high because it's a strong base. And this is the curve that you now need to draw. So you need to label your axes for yourself, volume of NaOH added, and pH up the side. And we are now going to fill in this graph. So neutralization always happens at the linear part of the curve. So if you need to get a ruler and put it over your graph, wherever it is completely linear at this jump, then that is neutralization. So it is the linear portion of the jump. Now, if we look at our indicators, all indicators will work for a strong acid, strong base, but we specifically use we use methyl orange as our strong acid indicator. So we use it when we do the HCl against NaOH, we use it when we do the sodium carbonate and HCl. We do it on the basis of a strong acid. So on the previous page, we said methyl orange has a pH range of roughly 3 to 5. So in terms of our colors, it is pink down here and it is orange up here. So that's why methyl orange works as an indicator, because either side of this jump, like this jump is happening in one drop. So from here to here is one drop of one drop of acid, one drop of base, because we're adding it this way. It is, so the color changed will just flip automatically. So similarly, we could actually use the phenolphthalein, and we've said the phenolphthalein works from the 8 to 10. So if we just put in 8 up here and 10, so here if we're using phenolphthalein, it's going to be colorless this side, and it is going to be the pink on this side. So again, the one drop, there is now a color change for the indicator. So either indicator would work. We use phenolphthalein. So the questions that they can ask is, you know, why did you select this particular indicator? And the answer that you would like to give them is that the color change coincides. So color change coincides with the sharp part of the curve, and with sharp rise on the graph. Now this answer will transport itself to the other type of titrations that you can do. So this is why we chose whatever indicator. I think that's right. So you just have to have the rough shape. So when I go back and told you what my numbers were, we said the numbers are 1, 3, 7, 10, and this will end at 13. So this is kind of telling you your plot. So for strong acid, strong base, you use all of the numbers. And it's kind of like this S shape. So that's strong acid, strong base. And any indicator is totally suitable for this. So this was a question that you had to do. Let's see what I want to do. So this particular one over here is going to go on the page 154. So on page 154, you are drawing a weak acid and you're drawing a strong base. So how do I know it's a weak acid? I know a weak acid because my pH starts high, and I know it's a strong base because it ends high. So we said our magic numbers. Now this was one you had to plot from data, but here we go 3, we go 7, we go 10, we go 13. So for a weak acid and a strong base, these are the numbers that we are hitting in our curve. And I'm going to put in the methyl orange markings. So here's methyl orange. Methyl orange wouldn't really work. We wouldn't see the end point because the color would have changed before we ever got to neutralization. So remember we said neutralization is the linear part of the curve. The linear part of the jump. And we've already changed color before we've ever gone to neutral. So we have down here that it would be pink, and we have here that it would be orange. And so methyl orange is not a suitable indicator for a weak acid strong base, and it's not the one that we used, so we can't use that. So we have a look at the 8 to 10. So the 8 to 10 for the phenolphthalein, it is colorless down here. It is pink up here, and we're now seeing the jump. So phenolphthalein will absolutely work as an indicator for this. And again, if they ask you to explain your selection of indicator, so to explain your selection of indicator, it's the same words as we had for strong acid, strong base. We're saying the color change coincides with a sharp rise. On the graph. So this is the graph that's on page 154. Okay, so starts high, ends high, and we have 3, 7, 10, 13 are going to be hit every time. So we've already seen these, and now we are going to look at, we've just done this weak acid strong base. So we've covered that. Phenolphthalein is your indicator. So now we have a strong acid, weak base. So this is on page 153. And if it's a strong acid, it will start low. If it is a weak base, it ends low. And by low, I mean close to pH 7. Oh, is that going? Okay, so if it's a strong acid, it starts low. And if it's a weak base, it ends low. So what does that mean? So here's ending low, it's ending at 10. So we're starting at 1, we get our point of inflection at 3, we have neutralization at 7, and it ends at 10. So it's 1, 3, 7, 10. So this time if we go pH 8 to 10, it's not going to work. We're not going to see the color change because it's already gone past neutral by the time we get there. So this is the colorless, this is the pink. Phenolphthalein will not work for a strong acid, weak base, but methyl orange, pH 3 to 5, will work. So here it is going to be pink, here it is going to be orange, and methyl orange will be a color either side of the jump. So this will work as our indicator. So again, if we have to explain our choice of indicator, it's the exact same words. If we have to justify it, and we are picking methyl orange because the color change coincides with sharp rise on graph. So strong acid, weak base, starts low, ends low. And the last one that we have to do is on page 155. So we have a weak acid and a weak base. So a weak acid in your head starts high and the weak base ends low. So this is now to get our S. It's going to start high and finish low. So for this curve, there is no sudden jump. It's actually not possible to get. So it is a 3. It is kind of a jump around the 7, and it is going to go to maybe the 10 at max. So this is a 3, 7, 10 data point, and it's a real squashed S. So there is no suitable indicator. So this starts high and it ends low. And there are no suitable indicators that can do this. So if you had to do a weak acid, weak base titration, you would use more than likely a pH meter to actually record when it hits 7. You'd be doing it drop by drop and recording it for when it hits 7. So this is just the summary that's going to go on page 156. And as we've said, you can use the color change coincides with the sharp jump on the graph, but strong acid, strong base will do all indicators. Strong acid, weak base, it is methyl orange, and when we did this it was, I think, HCl and sodium carbonate. I'm trying to think in my head. Yeah, and then when we do weak acid, this was the ethanoic acid against NaOH. And we also do a version where we do HCl versus NaOH. And when we do that, we do use methyl orange as our indicator, is our choice here. And that is the end of titration curves.